everyone, we meet again, Chemistry with Teacher Miza. So today I would like to discuss on hydrocarbons as fuel, and here we will cover on the combustion reactions of alkanes and how they are used in industry, and also we need to recognize the environmental consequences of these reactions. So let's go. First, you need to know what is complete combustion of alkanes. Okay, so alkanes burn in oxygen completely. Okay, when there is plentiful supply of oxygen, and to form carbon dioxide and water. So alkanes are good fuels as most burns readily to produce large amount of energy. So the longer the hydrocarbon chain, more energy is being produced. So they are used to power vehicles, and most countries' electricity are made using the combustion of alkanes. So this is the chemical equation of this reaction. So make sure that you still remember the definition of enthalpy of combustion. Okay, so enthalpy of combustion is when 1 mole of compound is burnt in excess oxygen to form carbon dioxide and water. So make sure when you write the chemical equation, the coefficient is right. So make sure the coefficient for the hydrocarbon compound is 1 here. And then you need to balance all this to have a balanced chemical equation. Okay. So let's look at incomplete combustion of alkanes. So this is quite tedious because there are the product is varies. Okay, alkane will when it is burned with limited oxygen supply, it will produce carbon monoxide and carbon, which is the soot, and this is incomplete combustion. Okay, so these are the example of the incomplete combustion of butane producing carbon monoxide. And at the second equation is when it produces carbon monoxide and carbon dioxide. So there are ways to write incomplete combustion of alkane. So make sure that you read carefully the instruction in the question paper. Okay, so this carbon monoxide is poisonous. Okay, why is it poisonous? So in our red blood cell, we have a structure called hemoglobin. So this hemoglobin should be bonded to oxygen to carry it to the rest part of the body. So instead of bonding with oxygen, it will bond more readily with carbon monoxide. So making that our body is less oxygen in our body. So it's very dangerous, and why carbon monoxide is poisonous. So this carbon monoxide is usually from cars and industry, so it can be removed by using catalytic converters. So this most of the modern cars has these catalytic converters. Okay, so another chemical equation of incomplete combustion is when it produces soot as the product. So these are the examples. So again, make sure that you identify that there is only 1 mole in each equation, 1 mole of butane in each chemical equation here. Okay, so this soot can cause breathing problems, make building dirty, and clog up engines. So it is an unwanted product. Yeah? So by burning hydrocarbons, so nitrates, okay, such as nitrogen monoxide are formed in the cars. So they are made when nitrogen and oxygen, which both can be found in the air, react together using an electrical spark. So this spark is actually coming from the spark plug in the engine to ignite the fuel. So this reaction will form nitrogen monoxide, which is in the atmosphere, it is harmful. So in cars, they have these catalytic converters. So what is this catalytic converters? The function is to reduce the levels of this pollution. So they are made from rhodium, platinum, and palladium alloy. So carbon monoxide, which comes from the incomplete combustion of the fuels, will react with this nitrogen monoxide. And this reaction will produce a less harmful gases, which is carbon dioxide and nitrogen gas. Okay. Another example of environmental consequences is photochemical smog. Okay, unburnt hydrocarbons and oxides of nitrogen contribute to this photochemical smog at lower level. So ozone occurs in the lowest level of the atmosphere, which is the troposphere part. So this exists when sunlight, hydrocarbons, and nitrogen dioxide mix together to form that ozone. So these hydrocarbons and nitrogen dioxide, which usually comes from cars and factories. Okay, so when solid carbon particulates mix together with ozone, it will create photochemical smog. And the picture here shows the photochemical smog in Shanghai, China, 2 years back, 2019. Also, during this duration, our country also face this smog. Okay, and it will this smog also, it is harmful to the respiratory system in the animals, humans, and also damages plants. Ozone also is toxic to human. Sulfuric acid arises from burning of coal and oil, mainly in power station, whereas nitric acid arises from exhaust pipes of our motor vehicles. You will see some of the effects of acid rain has on our environment. Firstly, it is important to understand that rain is naturally slightly acidic. Whilst falling to the ground, the rain dissolves carbon dioxide from the atmosphere to form carbonic acid, which with the pH of 6. It is when we burn fossil fuels that much stronger acids get into our rain to form acid rain with a pH as low as 3. When the pH changes from 6 to 3, what do you think the acidity increases by? 2 times, 3 times, 10 times, 1,000 times? Remember that each change of 1 in pH is a 10-fold change in acidity. So changing from 6 to 3 is 10 times 10 times 10 times 10, or 1,000 times more acidic. We will consider sulfuric acid first. Plants need a little sulfur to grow. They obtain it from sulfates, for example, potassium sulfate, found naturally in the soil. The sulfates are taken up by the plant's roots and sulfur atoms become bonded to carbon atoms in the leaf proteins. When plants die and eventually form coal and oil over millions of years, these sulfur atoms remain bonded to the carbon atoms. The sulfur content of coal and oil is usually between 1% and 4% by weight. What do you think is produced when fossil fuels containing sulfur are burnt? When the coal is burnt, the sulfur and the carbon atoms join with the oxygen from the air and are released into the atmosphere as carbon dioxide and sulfur dioxide. In the presence of sunlight, a photochemical reaction will take place where sulfur will react with more oxygen to form sulfur trioxide. This dissolves in the rainwater, forming sulfuric acid. Let's now consider how nitric acid gets into the rain. In the high temperature conditions in the cylinders of our motor vehicles, a small amount of nitrogen and oxygen from the air can react. Remember that air taken to combust the fuel is nearly 80%. So the exhaust gases from the vehicles contain small but enough nitrogen oxides. Once the oxides of nitrogen are in the air, they will react with more oxygen just like we saw in sulfur dioxide and dissolve in the rainwater to form nitric acid. If the rain falls on the limestone soils, which are alkaline, the acidity may be neutralized. However, if the rain lands on neutral or acid soil or vegetation, then it can cause damage. So, why is this acidity harmful to living things? Well, Living things don't grow well in acid conditions. It's easy to demonstrate this. Soak a slice of bread in vinegar and another in pure water. Leave them open for a little while, then leave them covered for a week. You will find that the bread soaked in vinegar has not gone moldy, whereas the other bread has. In fact, we use vinegar to preserve food in a process called pickling. This is the case because certain enzymes which are vital for growth are unable to function in acid conditions. The other main problem is in the soil. Whilst naturally occurring toxic metals such as aluminium are insoluble and therefore fairly harmless in neutral soil, they become soluble in acidic soil. They then get taken up by living things and take the place of essential metals such as zinc and iron. To add to this, the hydrogen ions in the acid rain will replace essential metal oils such as potassium, magnesium and calcium, which are normally held in the clay soil, causing these essential metals to be washed deep into the subsoil away from the roots of plants. So, to summarize, normal rain is slightly acidic due to the dissolved carbon dioxide, but acid rain contains sulfuric acid and nitric acid, making the rain 1,000 times more acidic and dangerous for many living things. Acid rain is a very dilute solution of nitric and sulfuric acid with a pH around 4. Now we will learn about ways in which we can either make this acid rain less acidic or at the very least reduce its negative effects on our environment. Can you remember where the nitrogen came from in a nitric acid and the sulfur in sulfuric acid? Well, the nitrogen came from the combination of atmospheric nitrogen and oxygen in the cylinders of motor vehicles, and the sulfur when fossil fuels containing sulfur are burnt, particularly in our power stations. Let's look at the power station in Europe. For many years, these stations have been using tall chimneys to disperse the sulfur dioxide far away, thinking that dilution is the solution to pollution. However, the acid did not get diluted, but instead was carried in the wind to Scandinavia, where it fell into Swedish lakes. Originally, people tried to neutralize the acidity by adding limestone to the lakes. This was partly successful. For example, salmon returned to some polluted rivers in Wales after the acidified lakes being neutralized. So a better method is to trap the acid before it reaches the atmosphere in a process called scrubbing. The kind of scrubber we need in this case is an alkali to react with sulfur dioxide. Also, either seawater which contains a little bit of sodium carbonate or lime calcium oxide is used. Can you think what reaction will occur with calcium oxide and sulfur dioxide? Calcium oxide react with sulfur dioxide makes calcium sulfite, CaSO3. The sulfide can be reacted with oxygen to make gypsum calcium sulfate, CaSO4, which is the main ingredient of wall plaster. These scrubbers have greatly reduced our sulfur emissions and given many countries much cleaner air, but it does reduce the efficiency of the power station by as much as 10%, thus increasing the cost of electricity. In oil refineries, sulfur is removed from crude oil by reacting it with hydrogen. This reaction is known as hydrodesulfurization, which takes place at high temperature with a metal catalyst to produce hydrogen sulfide, which is a bad smell and very poisonous gas. When this purified oil is refined into various fuels, it is virtually free of sulfur. So how to reduce nitric acid in rain? This time, we need to put catalytic converters in the exhaust pipe of all our motor vehicles. Essentially, they convert the oxides of nitrogen back into oxygen and nitrogen. So how do we monitor the pollution in the atmosphere? IR spectroscopy. is used to monitor the pollution levels by identifying bonds in pollutant molecules. So it is also used to measure how much pollutant is present. So IR spectroscopy, this method we can discuss more, and we can learn more about it in our later chapters, which is in our analytical chemistry. So it is very fun to learn about it, and this is one of the implementation of IR spectroscopy in industry. So I think I will stop here. So we will continue our lesson on alkenes. Okay, so see you next time. Bye bye.